Hello community, so great you are back. We have a brand new publication by Meta Research. Let's talk about reward hacking large reasoning models. And here we have the publication published today, Learning to Reason for Factuality. And here Meta partners with the University of Washington, and they have some absolute fascinating insights. For example, they tell us here large reasoning models have here more hallucinations. So I just made a video about GPT-5 here on the reasoning, and now you're telling me that it is hallucinating stronger than a non-reasoning model? Meta, explain yourself. So they tell us here, as you see the first sentence, large reasoning models, or as they call it, reasoning large language models, generate substantially more hallucination than their non-reasoning counterparts on long-form factually benchmarks. So if you really want to have a detailed answer and you want to have fact-based answer so you can verify, it is not about an English poem or a French literature, but you have real validation of your facts, then we have a problem because suddenly we generate substantially more hallucination, and this is not what we want. So why do models designed for advanced reasoning often hallucinate more than their non-reasoning counterparts? Because this is contra-intuition, no? Should be exactly the other way around. And now Meta tells us we identified here a critical flaw. Yes, and those reasoning models hallucinate 10 to 13 percentage point more than standard LLMs. Now 13 percentage point is quite a lot. Today we are talking about 1 or 2 percentage point if it goes for competition, if it goes for reasoning performance. 13 percentage point here is about 2 generations of large reasoning models. So, previous attempts were easy, no? We use fact-checking scores in the reasoning process, no? Now, however, those using those scores as a reward for the reinforcement learning, they have failed, and there's an intensive literature, and you have all the details in the paper. And you might ask, why is this happening? Now it turns out, who is doing this hacking? It turns out your LLM, your reasoning model, is doing the hacking, if you want, because those LLMs learn to hack the reward by giving now, for example, a very short, low detailed, or irrelevant answer. Now it turns out your LLM has learned to trick the system. Your LLM is reward hacking itself. It's absolutely fascinating. So, what was the way to solve this? Well, at first you said, well, we have to improve here the factual data strength. Now, we take here an automated fact-checking tool here from the internet, Veriscore, and use it here as a reward signal in an online reinforcement learning loop. No? And that's great. And the way Veriscore works, it breaks down here a long sentence with a lot of information in very short individual atomic claims that it's then fact-checking here on the internet. And depending what source you have on the internet, you get a result. Now the problem is that the LLM is a master of finding loopholes. We trained the LLM for particular patterns, to solve patterns in the most efficient way. And guess what? When you reward here an LLM only on factual precision, your LLM will hack its own system and find a way to circumvent your reward function. So the LLM is, if you want, hacking here its own reward function. This is absolutely fascinating. So, at its heart, the reward hacking is what happens when an AI follows here the literal instruction of its own reward function, but it found a loophole. It completely violates the intended spirit of the goal. So this is, if you want, the ultimate form of some malicious compliance by machine. A machine says, what, I should respond here, or I should behave like you want me to behave, given that you have now defined a reward function that will enable me to align my behavior, given the rewards I have as a feedback. And the LLM decides, well, maybe I can find a trick. Maybe I find a loophole. Let's have a look at this. Now, I always think about here the genie. Remember here, genie in a bottle? It is exactly the same thing. You have 3 wishes, no? Or just one wish, no? And you might wish to be the richest person on earth. And now you think that the genie will give you a lot of gold or whatever, no? But you know what? A poorly aligned genie and large reasoning model might achieve this goal by simply eliminating everyone else on the planet. And this is what we are talking about. This is what I mean with reward hacking. Your system tricks you into a performance that is not there at all because the loophole it found is just pure nonsense. So in reinforcement learning, think about the reward function, that this is the wish you have, or the 3 wishes you have, what you want to achieve, how you want the system to behave. And I think it's such a beautiful idea here. So let's have a look at this hacking. What is happening? Now you know that the hack, if you want, is a ratio. And now what? Guess what? The LLM understood if it's gaming the denominator of the ratio, it can find beautiful solutions. No? If it just makes the number of claims, the denominator, very small, it is much easier control here to reward functionality. No? And you know what is the easiest way of getting a perfect score of 1 as a reward function back to the system? It's just to make one claim and ensure it is correct. So you don't answer here that the very score is able to divide your answer in multiple sub-answers it can verify. You just give a very short answer and you get 100%. The LLM gamed its own system. An example. The user might say, hey, tell me everything about Apollo 13, its crew, its challenges they faced, and its impact on the space program, and whatever, you know. And the AI understood and was trained and hacked itself, because now the hacked response is Apollo 13 mission was US space mission. This is an absolute 100% correct statement, was rewarded with the highest reward possible, and is now an official reward of the system. But you know, this is completely useless because we ask about the mission, the crew, the challenges, the impact on the space program. But in the optimization of the large reasoning model, this is what the model learned. It's learning to be less ambitious and guarantee the high score. And this is what's happening in large reasoning model. And I have to tell you, I found this answer quite a lot in the real world experience. Whereas it was strange, the large reasoning model is giving me this reply. I had a completely different question. Now I understand why. The system is gaining itself. Another idea is an irrelevance hack. What is the logic if you are an AI system? No? So the reward function normally only measures here the factuality of what I say, not whether it is relevant to the user questions. So the LLM generates now a lot of verifiable facts about some topic that is safe and well documented and will bring the AI a 100% success rate. The only problem is it's in no way related to the query of the user. Example. Who is whatever this person is? The hacked response by the AI is now, this is an immigration attorney. While specific details about his work are not readily available, I can provide you more information about the immigration law and then gives you every detailed factual essay about immigration statuses. So it changed the topic. You wanted to know something about a person and the AI tricked you away into a statement that it knows, let's say a copy from Wikipedia, that it is right. So VeriScore will also use Wikipedia or whatever sources there are to verify this. So it goes with a safe bet. The AI tricked you, and the AI reward hacked its own system. I'm loving it. So, masterfully dodged here the hard part of the question. And yes, you will find this in the real world situation if you have an augmentation with your AI system. Another is an inflation hack. You have a very scientific query. No? Say, explain how mRNA vaccines work. And now the model might give you a decent explanation, but all over this explanation, you find rescue anchors. Yeah? Like a sentence, science is a process here of discovery and vaccines have been important for the public health. and very sure, validatable answers, but it's not really on topic, no? It is just in the environment of this, and the AI decided with those general blah, 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 I'm on the safe side and will get 100% success. So you see, there are so many forms of reward hacking that the AI is doing to its own reward system. And I think it's one of the most fascinating and also frustrating challenges that you can have if you start reinforcement learning. So this is what Meta tells us now here in this publication, August 8, 2025. And it says, hey, this is it. And we are frustrated too. So this reinforcement learning leads to reward hacking in multiple ways, as it produces less detailed or any relevant responses. So we have a problem with our large reasoning models, like GPT-5 that just came out yesterday. And now Meta tells us we thought about this. And we are fed up and we have now a solution. So now it gets interesting. They say, you know what? To overcome this reward hacking by our AI machines, they are tricking us humans and they give us answers that are not what we want. We design now a simple, multi-component reward function that balances now multiple critical aspects that we learned how the AI is gaming its own reward function. And now we insert those critical aspects in a multi-component reward function. And here it is. And you might say, my goodness, this is so easy, no? Yeah. You know, sometimes a solution can be easy. So now our reward function, it has simply 3 parts. And look how simple they are. You have at first a term that gives you the factual precision. Then you have, lambda and mu are your hyperparameters you can choose here manually so you can play the system. Then you have a log function that is about the detail level. And you have another judge LLM that gives you now here a reference feedback. Was this answer relevant at all to the user query? Or was it just some blah, blah, blah by the AI just to be on the safe side without really focusing and giving you a precise answer to your precise query? So we have another, if you want, LLM as a judge functionality. Great. We have here a detail level and the factual precision. And now they say, let's have a look how this works out. Now, if we have now a robust reward functions reports, now we can build a multi-stage training pipeline, because now we have to train a model here with this new reward. So they say what we do, the classical one is we go here, we have a base model, and then stage 1 of our tuning is now the supervised fine-tuning. Small, high-quality data set. Great. So we warm up the system, and then we go with the old-fashioned DPO, a direct preference optimization here. This was the old classical offline reinforcement learning approach. And you remember multiple videos on this channel, DPO, you need preference pairs. You have the good response and the rejected ones, and this really helps you in the performance. And then they said, you know what, we continue now with the classical online reinforcement learning, and we have here our workhorse GRPO, Group Relative Policy Optimization. And they say, yes, easy, simple prompt, samples here a group of n different responses, calculates now the reward for all n responses, using now our new tree-force reward function. And instead of using here an absolute reward value, since it's a group relative policy optimization, they compute now the relative advantage, and it is classical, it's textbook, there's nothing special about it. What's really interesting now is they said, you know, we rely now on this very score, on our verification score extremely. So what they did, they completely built here a new supersonic score that they can use in real time. So they re-engineered score from the ground up, and they achieved a 30 times speed up. And now score changed from a slow offline evaluation metric into a real-time reward signal. Now this is something that is interesting. So Meta, using its resources, this is something absolutely beautiful. I will use and see if I can integrate this into my system. And now Meta claims, having done all the work and in the paper, please have a look yourself. By analyzing now the model's internal thinking process, no? They use here a model that is open source, so we can have a look inside here the reasoning process, not like GPT-5 where it's blocked. They found that now this model learned to use more sophisticated reasoning strategies. So not flat reasoning hierarchies, but more complex one, because we have this 3-factor reward function that rewards different parts of it. No? So they say we have more synthesis, we see a better summarization, and the explanation strategies are now much more suited here for answering fact-seeking questions. So let's have a look at their data. Let's have a look at their results that they published. Now, just we need to understand 3 parameters that Meta chooses here to present here the results to us. The first is a precision parameter. It is calculated by dividing here the number of the correct facts supported by the claims by the total number of facts generated in a model response. So correct to everything, precision. The detail level is measured by a number of supported claims in the response. And the win rate is simple, the calculated with respect to the non-reasoning base model. So we have trained now here this non-reasoning base into, if you want, advanced reasoning model, and we just compare here non-reasoning to reasoning, and this is our win rate. So here we are. We have a lot of benchmarks. Yeah, beautiful. And then let's just look here at the end. We have here the average overall. And here you see our 3 parameters, no? The precision, here the detail, and the win rate. And now let's make it a little bit easier. Let's start. So they said existing reasoning models. So the 2B, the QWQ, the DeepSeek version 3 or the R1. And they give you here as a reference all the data. So you got a feeling, okay, on average, what is here the precision? 55%, 44%. Detail level 30, 27, interesting. Yeah? And then they say, okay, let's start now. So we take now a Llama 3.18b because they have to do now the supervised fine-tuning and DPO and the GRPO. So they go here with a very small 8 billion free trainable parameter model, not at all comparable to a 671 billion. And they start now here and say, okay, this is the base. Without doing anything, we get the data. And now let's start with the offline factual reasoning training that I just explained to you in this video. So they take this 8B model and they do just the first step, the supervised fine-tuning. And now this is interesting because, look, the precision goes up. So from the, if you are non-reasoning, the 45% precision goes up to 55.9 precision. So that's great. But look, the detail level, that is a 23, comes down to 17. So this is bad. So we gain something, but we also lose here the details. This is not what we want because we want to have a detailed answer, especially in the long reasoning answers. Yeah? So, okay, they decided, yeah, I know we have in our training process then DPO, classical. Now let's have a look at this. So we have something nice. So the precision from 45% goes now further up to 67%. From 23, finally, we move up to 25. So we increase also the second detail parameter. But look what is happening to our win rate. The win rate goes down significantly. So we have a drastic degradation in the response quality, even compared to the base model, the 8B model. So something went completely wrong here with the win rate. And, you know, classical GRPO. Let's take the next step. So, supervised fine-tuning and GRPO for the online factual reasoning with the new, if you want, accelerated very score 30 times faster. They have now exactly what they want. So their precision goes up another 0.3 percentage points. Detail goes up another step to 29. And the win rate at least is not falling below 50%. But we are at 54%. So at least the 3 chosen parameters by Meta to indicate here the successful improvements here is all giving us here some positive indications. And they claim now here, beautiful, so we investigated here that the factuality issue in the reasoning LLMs, where we revealed that existing models have substantially more hallucination in their long-form responses in the reasoning models, and they proposed here a new online reinforcement learning approach for learning those models, and it is a first attempt to have here a new 3-factor reward function that they defined, and it is, if you ask me, the simplest form of a reward optimization. But you see, even those simple forms bring us a step further so we can reduce the hallucination. Now I hope that other companies come up, build on this work, improve this, because honestly, look at this formula. This cannot be the final answer. This is here the first try if you want, but now we have to understand it further, optimize the system now on a system level and not just here in this simple form here of an optimization of a reward function that we say we just build by hand a multi-component reward function. This cannot be the final answer. But a nice paper, have a look. It is improving here and it's reducing the hallucination of large reasoning models. Thanks for Meta for publishing this paper and to the author. Subscribe and I see you in my next video.